Hello, good morning everyone. I can see 7 views are here. Okay, I can only like how many people you are here in chat. Um, I think we should wait for some time. Can someone comment and tell me that I'm audible or not? Ah, I think we are ready to go. I think we should start. I'm going to share my screen. Yeah, cool. So, yeah, so the session, I think we should start. Yeah. So this session will cover all the basics things. So whenever you go in any organization and whenever you start working on a new project, there are few things you should keep in mind. And I am like combining all those things in this small session just to get you just to give you guys the idea about like how to work and how to start with anything. So like this session name is PyTales. So whenever we start any project, the first thing we do is create a virtual environment. So you guys can use two things, virtual environment or virtual environment wrapper. So you should know that where to use virtual environment and where to use virtual environment wrapper. They both have their own functionalities and uh, um, yeah. So virtual environment it is a tool, so like it create a isolate environment, and it is helpful when you have a different project with different dependencies. So it will never collapse anyone, and it will save your project in different things. And virtual environment wrapper is nothing, just a wrapper utility around the virtual environment, which help will when you have a very common projects around you. You are using a common project, and when you see that these dependencies are common, then you simply activate all that environment and use that environment dependencies for different projects. So I am going to share you guys. Okay, I have a reference. Yeah, yeah. So you guys can install virtual environment wrapper from here. There's a basic installation step you guys have to follow. Just install from here, and whenever you are creating a new virtual environment, just use this mk virtual environment and name of the virtual environment. Virtual environment wrapper will save all of the environment in a single place, not like a virtual environment where you have to save inside the repository. It create a like environment name inside that repository, and then you activate it and all. And using the work on work on space temp, you can activate it. So like, okay, let's start creating it. Yeah, cool. uh, so this is how you create a virtual environment wrapper. It will automatically activate it also. See, this is created. Just go to this and Let what you guys want to install. Pip install Flask. Okay, so you can deactivate this using simply deactivate. Okay, and whenever you want to start this, just use walk on and pilot this. Yeah, it will activate it. So this is the like very basics of how to use virtual environment and all. Next, we will move with the debugging part. Uh, I am putting this before because you should know that where your code is failing. You can use print statement like most of the time people I saw that using print statement and all. It's a good thing, but sometimes it's not good when you are running a long program. So you should use PDB or IPDB. It's like similar, just the I version of PDB. So it is a module from Python standard library that allow you to do conditional breakpoint, inspecting stack trace, viewing source code, and running Python code in a context. So we'll see example that how it will work. Uh, I will share this just after this if you guys, any one of you want it. Uh, or if you want it right now, I can share it on comments section below also. Yeah, I think I should share. Yeah, you guys can go here and like read after this session. Yeah. So okay, let's start our shell. You can use this Python -m pdb and whatever the scripts you have, and it will start debugging this. So like let's check an example of this small program. Let's not run this with the PDB. Suppose you are running a program of you put enter the list of numbers and you want to double those numbers, but when the output will come, then you see that it's not double, it's like tripling the number. Then at that time, what you guys can use is simply at the point where you think that it's failing, or just add the PDB, and using the pdb.set trace, you can trace the every line. Okay, now just call the same double element. So right now your cursor is on for I in n. It's not running. Like when you right now when you enter I, it's like nothing is there. Just use n for the next element, and then it parts through the for I in n as I in n, and now the value of I is 1, like list of 1. Okay, like first value from your list, and the cursor right now is on print I multiply by 3, and here you can see that it's like multiplying by 3 now, not doubling your number. And when you do next, then it will print this 3 value, which is multiply by 1. And when you do C, it will continue your process. See, doing continue, it just printed all of that. So now you know where is the problem. Just remove the PDB and you are ready to go. Yeah, see. So yeah, that's the debugging part. Now we will move to the things. Okay, so args and quarks. So uh, this is like in this args and quark, you should like only think about these asterisk because these are the thing which unpack the list dictionaries inside any function. It allow you to pass undefined argument to a function. Args is used to send a non-keyword variable length argument list to the function, and quarks allow you to pass keyword variable length argument to a function. Args mostly we use for a list of element, and quarks mostly we use for dictionaries. And if you have we can see the example now. Yeah. So let's see, we just declare a function with session, and this accept a args value. You can write anything with this. There is like you can use anything, yeah. Like there is no restriction of using only args and quarks, but mostly people prefer to use it because it's easy to understand and easy to maintain the code also. So here, like we defined a method session, and it's accepting a args. Like just now pass few things inside this. Mm, welcome to the session PyTales. And now it will print everything. So first f argument is what it take is the welcome, and another is the like list of argument or whatever you are giving is going inside this. Like there is no number of element which is accepting. It can accept n number of element. So that's what is another arg through args. It's two. It's the you can pass any list and unpack also. Like let's try doing this. Okay, okay. Why this is not callable? So yeah, like you guys can understand that what I'm just trying to say. Let's move to the quarks part. How it's working. Uh, yeah, let's get this. Oh, okay. Don't know what I mean. Yeah, and comma separated more value. You guys can pass. So this is how can we can just write the name of students and their roll number. Will print. So I want to show you here some one thing. Here you can see that we use format in this whenever you're printing. Like this is a good way of using, and uh, you can even change the position also. You can put one here and zero. So now it will print first roll number and then name. So let's just try doing that. We have roll number 11 and name of the person is Lily. Let's see that another roll number is 34 and name of the person is Rachel. Okay. What's happening here? Keyword can't be expression syntax. There's something I'm missing. Okay, let's just move to the next one. I don't know, like, so next part is the decorator part. So what decorator do? Function which modify the functionality of a other function. Like we use a small functions, and there are so many time when we see that things are coming repetitively. Then at that time we choose to create a function and use as a decorator. Like this is a common way of using, and that common use cases of decorators are like I used in authorization and login, synchronization, memorize and caching. And let's see that how to create your own decorator and like how to make a chain of a function decorator. To do that, yeah, we can do this. Yeah, there is a like very small example also. What this program is doing is it is taking the how much time it is checking how much time it is taking to run a function. So what we are doing is like here we simply we are like this function is written like timing function, and we are entering some function inside this. And what it will do, like it's created a wrapper. First it will t1 start, and then function will run, and after that we will just subtract the current time with the previous time. And we are using this timing function as a decorator here. Yeah, so we are using this timing function as a decorator here, and we don't need to write this thing again and again. We can use this timing function to a many other functions to run this. Let's see it's working or not. I don't know like why it's my previous program was not running. Let's see. uh, yeah, just skip this. So did I import it the time? Okay, this is done. Okay, let's check this now. Now print sum of numbers. So here it is. Yeah. So see what it does. So first it it entered this sum of numbers into this timing function, and now it is printing that sum of the all number. First it will print this function is running first, and then we are returning this total time of uh, process. Okay, so for sum of all number is this, and the time it took to run the function is this. So that's how the decorator work. You can create your own decorator also, and we will see in our coming slides with the class method, starting method, decorators, how to use this. Yeah, so let's move to the next slide. Yeah, exception handling. uh, why exception handling is important? Because it is an event that occur at the execution of a program, and unexpectedly it occur, and for some time you even have no idea that why it's coming, the error will come and all. So it help programmer to write a clean and error free code. It will stop your program unexpectedly, and that's very bad to stop instead of raising error, so that user and client should know that what's the input they are giving wrong, and what is the thing they should put correctly, so that it will not stop the program, and it will not give any kind of weird error. So it avoid your program to crash. And just like the other programming language, we here also use try and except to catch all the exceptions. So let's see one example of exception, like how to handle. You should know that there are some common error which generate, like when you divide 1 by 0, there is a zero division error. And when there is a which is not even defined, then it will give you a name error because it is not defined. uh, and if you like here you printed for D in data, but the syntax error is there. What's the syntax error? Because the name of the for is not correct and all. So you should these are the common error which is just showing you. These not come, like most of the time, like a name error you can see, input output error you can see. So let's check first few errors. See, the zero division error is coming. And let's right now you have A. When you print A, it will give. Just delete the A, and when you print A, then it's a name error will come. uh, you are trying to open a file. Just open a file right now. No such file or directory is available, so this is the error, and you should catch this error, or you should do. So here it is, like just try to open this file IDs, and you want to write in this uh, and accept input output error, and just print the error. Print the error, or you can continue this, or you can pass this, or you can raise this error also. There's a different way of handling it. Okay, so we have a directory with PyLadies. That's why it is not showing error. Let's change the name of this. Mm. Okay, write function will write like it will create and write. That's why. Okay, new session is already created, I think. Okay. Just try with session dot text. Yeah, so now you can see that error occur and no such file or directory. Write will so what write will do is, like, it will create file on go on fly, and it will write into that. That's why it was not accepting. So there are different way of handling multiple errors. If your file have different error, then you can handle using this input output error, accept value error, uh, and you can, if it is completely okay, then you can just pass this, and you can raise error also. And we have one more thing, you can see you can try nested try and accept thing also. Here I'm trying with the opening a file with a write. It will write this, like this is a test file for exception handling, and if it is correct, then it will finally close the file, and if it's not, then it will raise an error that can't find the cannot find the file or read it. So what finally do is you have it will execute all the try and accept statements, and it will finally do the things after finally will always run no matter what. It will not stop, and this finally is inside this try. That's why it will always run. You can even define finally after except also, like here after except also you can define the finally, and it will always run. It will never stop your progress or all. Or even you can overwrite something inside the finally. If it will always run, yeah. So this is how you write try some statement. You write some statements here and accept the handling. The try, okay. So the try block, there is a piece of code can raise exception, and that code can handle the exception. So we place inside the accept clause. Uh, Whatever the error is coming, we place inside that accept clause, and finally block will always execute whatever happen. Else block execute if there is a no error, and some common type of error we just saw is input output error, import error, value error, type error. And if we don't know what kind of error is coming, then you can simply uh, raise an error like accept exception as E, and just raise the error. You don't need to, like, this is the just I printed it. You can simply even raise it. Yeah. So like this is raised input output error. Yeah. So this is the basics of exceptions, that how you can use it and how you can make your code more cleaner. Next, we are moving to the iteration part. uh, what iteration is doing. So iteration is the process of taking one element at a time in a row of elements. So whenever you are using a for loop, while loop, then this is doing a iteration. It will run a single time. It will run a single thing every time till the program, till that element is not ended. So this is what the iteration is doing. Like it will run in a loop till the elements are not parsed properly. And iterable is anything that can be looped over. Anything you can call with iter that will return a iterator. So anything you can call with a loop over is like whatever is coming after for I in range. So whatever is coming after n is like you are looping over this thing. So this is the iterable part. And iterator is a self-iterable, means it has an iter method, and iterator has an object with a next method. There are three things: iteration, iterable, and iterator. And iterator has an object with a next method that return next value and signals when it is done by raising stop iteration. So when when you do next on the iter object, then there is a point will come when the your elements are ended and it's properly parsed for, then it will raise you the stop iteration error. Let's see with an example. Okay, iteration. Mm, yeah. Okay, let's see. We have a key. Hi, ladies. Yeah. Uh, right now, the type of this key is string. You want to make it iter, then just put this inside a iter block. Uh, your your key, and when you see the type of this iter now, then it will show that this is a iterator. Okay, now what we just see that it has a, like now we you can iterate with the object with the next method that can return the next value. So right now your cursor is on pi, like p, and when you do a next with the iter, it will be the print. Okay, you parse the p, next will y, and so on. Now it is completely done. Now when you do the next, then it will show you the stop iteration. See the stop iteration, because there is nothing to iterate on this string. You can iterate on anything, string, list, whatever you want to iterate on. So this is when you get the idea of iteration, then you will know that what the generator is. Generator is similar to the iteration. It is also iterable, but you can only iterate over them once. You can only use them once. So for that we use yield, because that value because yield generate the value on fly instead of storing into the memory. And instead of using return, we use yield. uh, let's see the example. Yeah, like you want to square any value, and you have, okay, sorry, yeah, for I in n, and you have a number and you want to square all the numbers. Yeah, fair. So when you will run this program, then it will return you only a single value. It will not store all value, and just say you are passing 5 and you are expecting to get so many values in this, but you will not get. Okay, yeah, okay. Yeah, yeah. So to solve this problem, we can use yield. What it do is it store all the value in a single list, and it will give everything in a it built everything, it store everything on a fly, and it will return you the whole list. Now when you do a square of 5, then this give you a, this is showing that now you can see that generator object at square is at this, and when you want to print it, just list it and it will print all of the value. So this value is stored in the generator, and now you can see that using the list that what's the value inside the generator. So this is the reason you use yield. You guys are with me so far? Yeah. So next we have is zip. Like zip has a, like very, zip is a very powerful function. What zip do is zip map the similar index of a multiple container. It work on a list tuple dictionary. It return the iterator of a tuples. That's why I give you introduction of iterator and generator before going and jumping into the zip. And whenever you zip containers, then the first ith tuple contain the ith element from each of the argument sequence. You can use zip to zip the argument, and you can use zip asterisk to unzip that an element. I'm going to show you a very good example of uh, how to use a zip. So let's simply see that what zip is. You have to list. You want to zip this now, just pass the list. See, the first element from your first list is combined with the second element of second list. So this is how you zip. And if you want to unzip this, I think you have to store this inside some data. And you have list 1 comma list 2, and just unzip it with the asterisk and with the zip. Yeah, now you'll get again that value, list 1 list 2 list, yeah, list 1 and list 2, you get all the value. So there is a like example I saw that's like, it's a very good example of how to use, how zip power, how much a zip is a powerful. So there is an index ABCD, and the first list is 1 2 3 4, and second list contain this value. And what kind of output we need is uh, the ABCD will convert into the key, and it will convert the first list and second list into a dictionary value, and the key we have is FK1 and FK2. So this is the like very a good example. Go I just figure out. So like just see that how zip is powerful now. So we have an index value, and our first list is this. Everything. So before, I think going to a like big comprehension, we should see that what zip is doing here. So it zipped the A15, B26, C37, D48. So this is what it zipped around, and we are using comprehensions uh, to make to get this output. And now when we print this output, to see that how zip is powerful, it just take the key one, like A, value 1 is 1 and value 2 is 5. And this mapped to the key one, that key one we have is the FK1, and key 2 we have is the FK2. And the value 1 which passed inside is this 1, and value 2 is 5. So now the output is A FK1, which has the value 1, and FK2, which has the value 5. So this is how it gave us the complete output of what we wanted. So this was the example of zip, and you saw zip. Now next move to the comprehensions. Comprehensions allow sequence to build from another sequence. Like it's a very good, you can say a one-liner thing to do. It's a very quick and good to do. We will see the three type of comprehensions we have. One is list, set, and dictionaries. That how we can use this. For list comprehensions, like we want square of a number, we just this comprehension is nothing but it just work like a for loop, but we use in this a single line to get the output of this. So uh, this is the like for s in range 10, and we just printing s2. So let's check first with the for loop. Range 10. Now just print. So this is what we get. And we are doing the same thing inside the comprehensions also. We are using this s multiply by 2, like s square of 2 for before, and then we are doing our for iteration in this. And we will get the list of square. So this is the list comprehensions. Now, dictionary comprehensions. So we have an example of dictionary, like we have a dictionary and we want to update few fields or value inside this dictionary. We can use this. And if you, so let's see that this new dictionary, what it is doing here, uh, if, so first of all, whenever you are looking into any comprehensions, first see what for loop is containing, what kind of thing it is doing. For dictionary, what how we iterate is using the items, and key and value. Key is the yellow and value is 5. So this is how we iterate. And next you can see here is if length of a k is 4, it means length of this dictionary contain the length of every um, color. Yellow has length 5. No, it's a 6. Okay. Red has length 3, blue has 4, pink has 4. It's just a typo mistake. If length has a key which it's greater than 4, then what it do is it perform this action. Key will be the same and value will be increases by 1. Let's see the example now. Let's run this. And now you will see new dish of orange 6 and yellow 6. So what is does is whoever has the length greater than 4, like yellow has a length greater than 4 and orange has a length greater than 4, it just took the that element from the dictionary and it just incremented the value of that element by 1. You can perform more operation in this. Uh, you can increase every value by 1, like you don't need to put if condition, else condition. You can simply do this as well. See, so every value is increased by 1. So this is the dictionary comprehensions, and now we will see the set comprehension. We'll see the same example like square. uh, So what set is doing is like if you have a common element inside any set, then it will remove, it will not print that repetitive element. It only print the unique element. So this is what is doing. Let's pass more element inside this with the same. So it will remove the repetitive element, double element, whatever is coming, and it will only print, it will only give us the square of the required element that we want. So 149. So this is the simple set comprehension. Yeah. So next we'll move to the slicing. So slicing is a very good part. What it do is like uh, it apply on the both list and string as well. You can slice the element from start end, and you can even add the steps you want to slice. Uh, yeah. Okay. I have example slicing. So yeah, this is a good example of like we have a Python, and if you want to slice this, uh, let's check this. You can slice the string as well, str. So you are starting with 0 and you are ending with 5. And if you want step, just see the start and end first, then we'll go to the step. It will print till the 5. So this is the 0, 1, 2, 3, 4, and 5. It will print before the 5. So this is what is doing. This is the 0th element, first, second, third, fourth. And if you want to print something from the end, then this is the -1, -2, -3. This is how you can print. Let's check this one more time. See, so it will print till the minus one element, that is n, and it is starting with the front. And like if you want to print only from the minus third element, you can print ho. You can also print from the second to the fifth position. See, so this is like it is printing. I also want to show you that what slicing return the copy of a whole array. uh, Let's see, we have a array which element 1, 2, 3, 4, and we have a b. What we are doing is we are assigning b to a. So when we append or add or pop anything from a b, it will reflect in the a as well. You can see in the a as well, it is reflecting. So we use slicing. So now when you do A, then B has the copy of whole array. It is not refer to the A, it is B contain the copy of whole array. And now when you, let's see the what value of A and B we have right now. When you append anything inside the B, it will only append inside the B. See, and it will not affect to the A array. So this is the difference, and this is a good example of a slicing, you can say, to understand what it is. Uh, let's say you have a, we had the string, right? Python. Now, yeah. Let's say you want to reverse it, and sometime you want to see what's the palindrome of it. Then what you can do is you can simply reverse this. See, so this is reversed. So slicing is good for reversing also. And let's see, you have a very long string. Yeah. Uh, and now what you want to print is str starting from second element to the end and skipping the every second element. So what it is printing, it started from the second. So it's starting from the L, it printed the L and it skipped the mm, script the two element, second element 2, and it's printed rest of the elements. So this is like the step function, step what it do. Yeah, item from the beginning through the n minus 1, and item start through the rest of the array and copy the whole array. So this is you can use to copy. Yeah. Next we have like uh, Python have so many built-in function like lambda, map, filter, reduce, and they have their own advantage. uh, so let's first see what lambda can do. Lambda is a nothing but it is a it is a function or a one-liner function or a anonymous function which is used for a very for to do a very small operation. We have a tool list here, and we zip this list. So the data is this. Now you want to unzip this. You can use lambda, and this will give you, yeah. Okay, I forgot one step, I think. Yeah. So what we are doing here with data is, what data we have it. Okay. So we have this data. We are sorting this data, and this data is sorted, and now we want this back inside our list. So this is what it is doing. Now we have list 1, which is completely sorted, and list 2, which is also completely sorted. So this is what lambda is doing here. So what lambda is doing is you just write a built-in function lambda, and with the value t, and whatever that value is passing from where it perform the operation on the t. The t is coming from the zip data. So and it is listing that value. It is unzipping the value, and the first t is nothing but just the list 1, which is getting the list of t. Uh, so the data 6, 3, 7, 19, 34, 67. This will get inside a single list, and the second element of every tuple will get inside the list 2. Yeah, so lambda, what lambda is doing, it is converting it into a list and saving inside the list 1 and list 2. So this is where we use lambda. Now second, we have a map function, and what map function do is it applies a function to all the items in the input list. And I think we saw here also it this is the function lambda, and this is applying uh, so function is there, and then we give so many inputs inside this, and inputs are applied inside this function. Let's see, we have a function which increment every element by 100. Okay, which return every element by increasing its value by 100. Now we have a map function here. So what this will return is, it will return a list which will increase element by 1. You can pass number of like n number of elements and item inside this array. Let's suppose we have an item with 3, 45, 69, 81, 91, and 100, and you want to pass inside this map. Pass it, it will increase by 100. So this is where we use map. Now we have a reduce function. So what reduce is do is it is extract the element in the sequence for which the function return true. If your condition is true, and if anything is true, then only it will extract the element. And it so this filter field also have the same we use the same like we used for a map function with inputs. So here we are using filter. So what filter here doing is, filter is taking, let's not do with the list first. Let's see that what filter is returning. See, okay, we don't need list. Yeah, cool. So we have this function lambda here, one line function, and we have a range from -5 to 5. And it will only return if x is smaller than 0. So x, so it only return after the value, it only return the negative value, not the positive value. We can change the we can change this condition with 3. Let's see, and it is printing. So this is what it's true, that's why it is returning this thing. Now reduce. So what reduce is, the reduce perform the computation on a list and it return the result. uh, you have to import reduce with and from the function tool, then only you can use it. Let's suppose you want a product of value, it will give you the product. So here you can see that how reduce is working. Next, we'll move to the class method versus static method. What class method is and what static method is. Class method work with the class since its parameter is always the class itself, and class method can modify a class state also, and that would apply across all the instance of a class. You can modify if you are using a class method. We generally use class method to create factory method. Factory method return class object for different use case. To use a class method, we use decorator at the rate at class method to define the class method. We know that how decorator is working. Next, we have a static method. How static method is different is like, class method work within the class, and static method knows nothing about the class and just deal with the parameter. uh, Inside the class method we saw that it can modify the state of a class, but static method cannot modify the state of a class, and static method cannot access and modify access any element. This is the utility type method that takes some parameter and work upon those parameters only. It will not work on the class parameter. For that we use class method, and for to use some method as a static, we use static method decorator to define this. I have an example of this as well. Yes. Hmm. Yeah. See. So here is a person defined, and it is initialized with the name and age. And what class method is doing is, it is returning the name. It is accepting the year as well, and it is modifying. Sorry, it is modifying it, and it will return you the age only. And what static method is doing is, static method is checking on the current age only, that it is you are adult or not. Let's take this example. uh, Self dot name is equals to name, and self dot age is equals to age. Now we'll use static method to check that someone is adult or not, and we'll pass only age. Yeah, yeah, we'll only pass the age. Return age is greater than 18. It will return the boolean value. Now class method. Fine. What's this? From birth year. Okay, from birth year also you can see what's the age of the person, and you access with the keyword CLS. Yeah. Okay. We pass the name and year. Yeah. And it will return the class. I think I have to import date also from date time. Import date. Yeah, let's see the person. Lily with the name and age is 23. Now when you see the person age, oh sorry, and person name, it is this. Okay, now let's see what's the person. This person is adult or not. You can pass here person dot age also. Yeah, it's true. It's adult. Adult. Let's create another person. Person two. Person with the same name. Lily. It's okay. Rachel with the age 23. Let's pass right now from the class method. From birth here, what will pass? Uh, Rachel and 1995. This is the year of birth. And yeah, okay, yeah. So you can do like this as well. Yeah. So now when you see the person two with the age, see, so this is matching the age. You can even pass the year and you can see that what's the age of that person. You can do like this. You can see that person is adult or not, which is static method. So what's class method is doing, you are changing it. Yeah, and this is applying all over the instance. Even you are doing all the change inside this method, still it is changing inside all the instance. And whenever you even call with the person to age, you are getting the exact age. So here is the difference of static method and class method. And what static method is, it's only checking that person is adult or not. So that's what starting method is doing. Now we have a super. Okay, that super is a very good thing to use in a multiple inheritance. And the reason we use super is so that a child class that may be using cooperative multiple inheritance will call the correct next parent. When you are using a single inheritance, then there is a no problem, and you will not see any kind of problem. And there is, I think, even not a use of super also, but it's good if you use it. But when you use a multiple inheritance, and when you stuck and when you see any problem of like a diamond problem and all, then at that time a normal inheritance will not work, and you will see that your siblings or child class is calling the parent class again and again. So for that, and to overcome from that situation, we are using the super. The real benefit come with a multiple inheritance, and you will see inside the multiple inheritance, when using super, a single call will not only automatically call method of all base type in the correct inheritance order, but it will also make sure that the each method is only called once, not multiple times. Like this is the diamond problem. Like B is inherited from A, C is inherited from A, and D is inherited from B and C. and B and C is both inherited from A. So when you do a normal inheritance, then you will see from the MRO that A is coming again from the B as well and the C as well, and this is like uh, coming repetitively, and this is not a good way of using multiple inheritance. And to escape this thing, we are using super. Uh, let's use without super. We have like simple class here with which is printing A2. We have B2 here, which is inherited by A2, and it will first go inside the A2 and then it will print B2. So this is how C and D is inherited from C2 and B2. So this is the like very basic without super. Now when you call B2, what it does, you can see the error here, that first it go from B2, and B2 is inherited from A2 and it printed the A2, then it printed the B2, and this is finished. And yeah, and then it is going in initializing the C2, and C2 is again, you can see, and this printed A2 two times, which is wrong. And to overcome from this, we are using super. You can even see d2 dot mro. Yeah, you can see the even sequence also. It is d2, then c2, then b2, and then a2. With the use of mro, you can see that what's the sequence of inheritance. Here we are using the super inheritance. So when now you will print it. Okay. Uh, what I did wrong. Super take at least one argument. Okay, I think this is inside the Python environment problem. Okay. Uh, this is accepting Python 3 and I have a Python 2 installed. Mm, yeah. Yes, sure. I am sharing you the diamond problem guest. Mm, okay, I don't know why I can't paste it. Come on. Am I offline? Um, I don't know that why I cannot paste it here. Like, is it okay if I give you the link after this session? I can show you here. This is the diamond problem. A, B, C, D. You inherited B, C from A, and D is inherited from B and C. Oh, thank you so much for your support. Yeah. Let's see, let's jump into the problem first. Yeah, so there is a two way of defining super. So this, I think my environment is not supporting, and this is written in Python 3. So what, how Python 2 is doing, uh, Python 2 will do like this. A, let me check with the single. Mm, okay, it will take self as well. Okay, I have to check that. Let's open a shell with Python 3. Like this is a Python through, that's why like it is not supporting. I forgot that how to do in Python. Yeah, let's move, and we can do here. Okay, so we can do in Python 3. Yeah, yeah, I did hit here. Yeah. So now you can see that how you can use super. There is a different way to use super inside the Python 2 and Python 3. Right now, I just forgot that how to use in the Python 2. Uh, I'll I'll show you, and I will add inside the gist, and I'll share you that gist. But you can see here with the super, it is not repeating. It is like coming from it is going first to the A, B, C, and D. You can even change the order if you want inside this. You can print A before and then super. So see the see now you can see change the sequence as well. If you so whatever the argument you are passing first, it will print for it will go to that argument first, that, and then it will call the super. So this is what is happening here. So first it is printing D, then it is going inside the C, and inside the C first it is printing C, and then it is going inside the B. uh, so this is how super is working, and this is where super is helpful. I'll try to share again. uh, if I can. I don't know like why it's not pasting here. Don't worry, I'll share you this just again. So I can show you here. So this is the diamond problem you face. B is inherited from A, C is also inherited from A, and D is inheriting B and C, which is containing both A. So this is the problem you will solve using the super. And here the super is useful for multiple inheritance. For single inheritance, you can use it. But you can use it, but it's not uh, like it's necessary and all, but it's good to use if you are using super. So this is yeah, so here you can see again, if you will read this, reason we use super is so that child classes that may be using cooperative multiple inheritance will call the correct next parent class function in the method resolution order. You can see with the MRO here also that MRO. Okay. Okay, I think Python 3 don't support this. Oh yeah, support it. Okay. So it is going first inside the D, then C, then B, then A, and then the object. Everything inside the Python is object. So this is what the super is doing. So yeah, that's it. I'll share the gist on Twitter also if you guys can come from that, and I'll live this. You can go to my GitHub also, and you can see gist also. I'll make it public. I'll make it public. I don't know that why I cannot paste it here. I'll share it with you guys. So that's it from my side. Uh, yeah. So I'll stop screen sharing now. Okay. So that's it from my side. I'll make the gist public. I'm just making it public. I think it's private. You guys can see, and if you guys can answer, if you guys have any question and suggestion, you can even comment on the gist also. I would like to improve, and I would like your suggestion, and I would like to help you more. That's it. Thank you from my side. Have a good day. Bye.